So the geometric mean has two different theorems that we can use to actually find a segment length in some of these similar right triangles that we are working in some previous videos. The first one is the geometric mean altitude theorem, and that says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. And so we see that right here, CD is my altitude. And it's separating this side AB into two segments, AD and DB. And this theorem tells us that the length of the altitude is the geometric mean of the two segments of the hypotenuse. So just what we were doing in that previous video. And so that means that CD squared is equal to those two segments multiplied together of my hypotenuse that CD created. So AD times DB. And the reason why this is the case is because of these being similar right triangles. So just like we were working on in those previous videos with similar right triangles, we can kind of get this from the proportions that we get from using the similarity. And so this is going to be the same thing as CD over AD is equal to DB over CD. So what I did was I just cross multiply, so CD times CD, you get the CD squared, and AD times DB, you get this right-hand side. And so this is going to be the case every time. So if we're wanting to find the altitude and we have these lengths AD and DB, we can go ahead and use that geometric mean. Similarly, the geometric mean leg theorem tells us that in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So just like we saw in that previous theorem. However, this one says the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So again, that just means right next to. And so this one's going to be looking a little bit different. And so the equation that we get for here, because I have my two legs AC and CB, is CB squared. So if I'm looking at CB, it's going to be equal to the geometric mean of the hypotenuse, so AB, times the segment of the hypotenuse that is adjacent to that leg, so DB. So the one that's adjacent to it right now is DB. So it's going to equal to DB times the entire hypotenuse, so AB. Similarly, when we're looking at the other leg, so AC, that's going to be the geometric mean of the segment right next to it. And so the segment right next to AC is AD times the entire hypotenuse, AB. So let's look at some examples of using these two theorems. So when you're looking at these, when we're finding the value of the variable, you're first going to be looking at, okay, am I trying to find the altitude or am I trying to find the leg? Because that will determine which theorem you're going to use. So here I want to find the value of x. X is my altitude, so I'm going to be using that first theorem. And that first theorem told us that it's going to be the geometric mean of the lengths of the two segments of the hypotenuse. And so I'm just looking at what the two segments are equal to. So that means that this equation is going to be set up that it's going to be x squared. It's equal to my two segments multiplied together, so 6 times 3. Well, 6 times 3, I get 18. And then I'm going to go ahead and take the square root of both sides to get rid of that square. I want to simplify my radical, so I see this 18 can be broken into 2 and 9. 9 can be broken into 3 and 3. So I see a pair of 3's can come out, so I have x is equal to 3, and I'm left with a 2 under my radical. Okay, looking at number 2, I first want to see whether I am looking for an altitude or a leg. I see that y here is the leg, so I'm going to be using my second theorem. And my second theorem told me that the leg is going to be the geometric mean of the lengths of the hypotenuse and the segment that is adjacent to that leg, so right next to. So this is going to be set up as y squared is equal to, first I'm going to look for that segment of the hypotenuse that is right next to my y, and that's going to be 2. So it's going to be 2 times the entire length of the hypotenuse. And so to find that entire length, that's just going to be 2 plus 5. So y squared is going to equal to 2 times 7. 2 times 7, I get 14. And then when I take the square root of both sides, 14 can just be broken into 2 and 7, so I can't reduce it anymore. So that means that y is just going to equal to the square root of 14. Okay, look at one last one. First, I need to see whether I'm given the altitude or the leg. Here, this is going to be the altitude, so I want to use that first theorem. And that first theorem told me that's just going to be the geometric mean of the two segments of the hypotenuse multiplied together. So I need 4 times 9. So I have x squared is equal to 36. And then when I take the square root of both sides, I get that x is equal to 6.